We start by defining a payment app class. This groups the user's balance together with the actions they can perform, making the program easier to reason about. Next, we define the constructor. It's the first method that runs when you create the app, and it prepares the internal state you'll rely on. Here we set self.balance to 0 so the user starts with an empty account. This is our single source of truth for money. This method is used when the user wants to add funds. It accepts amount and will update the stored balance accordingly. We increase self.balance by the provided amount, simple arithmetic that persists inside the object for later operations. Then we print a friendly confirmation including the emoji in the new balance so the user immediately sees the result of their action. This method handles outgoing payments. It takes an amount and ensures we don't let the balance go negative. First, we check whether the requested payment exceeds the current balance. This is our basic safety check. If funds are insufficient, we inform the user clearly with an emoji and do not change the balance. If the balance is enough, we proceed to deduct the amount. The else branch is the successful payment path. We subtract the payment amount from self.balance, updating the persistent state inside the object. After a successful payment, we print confirmation along with the remaining balance so the user knows what changed. This small method is your read-only accessor. Call it whenever you want to display the current balance to the user. It prints the balance with a money emoji for clarity, useful feedback for the user's next decision. Outside the class we define main, which wires up the interactive loop. This is the user-facing part of the program. We instantiate payment app so we have a concrete object, app, to call methods on and to keep state in between user actions. An infinite loop displays the menu repeatedly until the user chooses to exit, a common pattern for simple CLI apps. Each iteration begins by printing a header. The \n adds a blank line so the menu is visually separated from previous output. Option 1 prompts the user to add money to their balance. Option 2 is used when the user wants to pay someone or something. Option 3 shows the current balance using the view_balance method. Option 4 stops the program and exits the loop. We read the user's choice as a string so we can compare it against the menu options below. If the user chose 1, we branch into the add money flow where we'll ask for the amount to add. We prompt for the amount and convert it to float so decimal amounts are supported. Note that in a robust app you'd validate this input. Then we call add_money on our app object to update the stored balance and show confirmation. If the user chose to, we move to the payment flow, which similarly asks for an amount to pay. We read and convert the payment amount to float just like in the add money path. Calling make_payment will check balance sufficiency and either deduct the amount or print an insufficient funds message. If the user chose 3, they want to see their current balance without changing anything. We call view_balance, which prints the current stored balance with a money emoji for clarity. If the user chose 4, they want to exit the app and stop the loop. We print a friendly goodbye message before terminating so the user gets clear feedback. Break exits the while true loop, which effectively ends the interactive session and returns control to the caller. If the input didn't match any valid option, we handle that here to keep the program user-friendly. A clear error message asks the user to pick a valid menu number without crashing the app. This guard ensures main runs only when the file is executed directly, which is useful if you later import this module into tests or other code. Finally, calling main starts the program so the user can interact with the payment app immediately.